So, I welcome you to the lecture series on practical machine learning using Python. And today, our topic is regression and more specifically, linear regression. So, what do you understand by regression? Regression searches for relationship among variables. For example, you can observe several employees of some company and try to understand how their salaries depend on the features like experience, level of education, role, city they work in, and so on. So, what we are trying to do, we are trying to find out the relationship among the different features, that is, different variables. Like in this case, what we are trying to search, we are trying to search the relationship of the salary with respect to with experience with suppose the relationship of the salaries with level of education and then role city like that, okay, how they relate to each other. So that is the regression. I am defining it again. Regressions means trying to search the relationship among different variables. So this is a regression problem where data related to each employee represent one observation. Okay. Every employee, for each employee will have one observation. The presumption is that the experience, education, role, and city are the what? Independent features. Okay. But salary, as the salary depend on them, so salary is what? Is dependent feature. Okay. Now, why or when do we need regression? We need regression to answer whether and how some phenomenon influences the other or how several variables are related. I'm repeating again, we need regression to answer whether and how some phenomenon influences the other or how several variables are related. For example, we can use it to determine if and to what extent the experience or gender impact the salary. Suppose I want to find out how the experience impacts salary, whether it is increasing with respect to more experience or how the gender impacting the salary. Suppose if gender is female, then the salary is increased or decreased in that way. Okay. Regression is also useful when we want to forecast a response using a new set of predictors. Suppose we could try to predict electricity consumption of a household for the next hour given the outdoor temperature, time of day, number of residents in that particular household. So, one point you again note down that regression sometimes used for forecasting a response with respect to some new set of predictors. Like these examples, what happened? We could try to predict the electricity consumption of a household for the next hour. And what we are provided, the outdoor temperature, time of day, and the number of residents in that particular household. So that's why we need regression. I hope this point is clear to you. Now, coming to today's main part of the discussion, that is linear regression. I hope you already gone through the linear algebra portion, as I have given some assignment on it and I have discussed them in my lectures. So you know that the term linearity in algebra refers to a linear relationship between two or more variables. And if we draw this relationship in a two-dimensional shape between two variables, what we'll get? We'll get a straight line. Now, linear regression performs the task to predict a dependent variable value y based on a given independent variable x. Is this clear to you? So, what we are trying to do for linear regression? We are trying to perform the linear regression to predict a dependent variable value y. Say dependent variable value y, and that is our dependent variable in this case is say y. Okay, based on the given independent variable x. So we are trying to predict the value of y with respect to x. Y is the dependent variable and x is the independent variable. So this regression technique finds out a linear relationship between x, that is our independent variable. So in this case, the input is x and y is the output. So we are trying to establish a linear relationship or trying to find out it between x, that is input, and y, that is output. That's why the name is linear regression. So I hope you have got it. What is linear regression and why the term linear comes here between this relationship. Okay, so that is the that is the fact why we used to call it as linear regression. So if we plot the independent variable x on the x-axis and dependent variable y on the y-axis, I hope you all guys are aware with the coordinate system with respect to origin and x-axis and y-axis. So what we are trying to do, we are trying to plot independent variable on x-axis and dependent variable on y-axis. Then what would happen? Then we'll get linear regression as a straight line that best fits the data points as shown in this figure. Consider this figure. You see these dot blue dots are our data, and this line is this red straight line is the regression line, and in this case what? Linear regression line. So x-axis, what we are considering in the x-axis, or on the x-axis we are considering the independent variable, and the y-axis we are considering the dependent variable. And when we are trying to plot it, we got this straight line. So that's the diagrammatical representation of linear regression. Now, you know this equation for this line, okay, will be what? Y is equal to mx plus b. And what is b here? B is the intercept and m is the slope of the line. So basically the linear regression algorithm gives us the most optimal value for the intercept, that is b, and the slope, that is m, in 2 dimensions. Okay, now y and x variables remain the same since they are the data features and cannot be changed. The value that we can control here are the intercept, this b, and slope m. As y and x are fixed, because you know these are our what? Data features, so we can't change it. So what we can control out of these equations is the value for the intercept b and slope m. Okay, so there can be multiple straight lines depending upon the values of intercept and slope. As you change the value, you will get a different straight line, isn't it? So if you change the value of m, if you change the value of b, then obviously you will get different straight line. That's why I mean to say that you will get multiple straight lines depending on the values of the intercept and slope. So I am coming to the concluding point that basically what the linear regression algorithm does is it fits multiple lines on the data points and returns the line that results in the least error. You should note it down. Obviously, as we are getting different lines from this equation, so we try to return only that line which best fits which is giving the least error. So that is our linear regression. Linear regression, I hope this concept is clear to you. So today's question is why we use linear regression and what are the conditions that impact linear regressions. Do answer in the comment. So thank you. Bye-bye.